Hi guys, my name is Dimeji. I'm an automation engineer at Zip Automations, Lagos, Nigeria. Today I'll be taking you through our industrial networks and systems integration automation rig at our training facility here in Lagos. Here I have a Schneider M241 PLC, an Allen Bradley Micrologix 1400, a Siemens S7 1200 PLC, and a PT100 temperature transmitter. The PT100 transmitter is connected to our S7 1200 PLC. The S7 1200 PLC reads the data from it and then transmits the data to the Micrologix 1400 and the Schneider M241 PLC over a Modbus TCP network. The different PLCs then push the data to their respective HMIs. The Schneider M241 PLC transmits its data to the KTP400 through Modbus TCP because they are from different manufacturers. The Allen Bradley Micrologix 1400 transmits its data to the panel view HMI through Ethernet IP, which is an Allen Bradley protocol, and the Siemens S7 1200 transmits its data to the KTP1000 through Profinet, which is a Siemens protocol. The data is then aggregated and transmitted to our SCADA PC here through something called an OPC server. Typical applications of this are where you have devices from different manufacturers that need to share data over an industrial automation network. So I'm just going to show you the little program that we have written for this application. Here I have my Modbus TCP block to actually write data. The S7 1200 PLC acts as a client while the other two PLCs act as server. This is the block we have written to actually read data from the temperature transmitter and convert it into a readable form. In my Schneider PLC, this is the program we have actually written to read data from the S7 1200 and the Micrologix 1400. So I'm going to be showing you a quick demonstration about how this works. Here I have my temperature transmitter, I have cold water and I have hot water. On the HMI you can see that the current temperature is around 29 degrees. So I'm going to remove the transmitter and place it in hot water. And you begin to see that the temperature is increasing now, it's 31. And on our trend here, you can also see the increase in the temperature. If you go to the panel view HMI, which is connected to the Micrologix 1400, you can also see that the temperature is increasing and our trend also shows the same thing. On our KTP400, which is connected to our Schneider, you can see that the temperature is increasing and our trend also shows that the temperature is increasing. So what I'm going to do right now is I'll remove the transmitter from hot water and place it in cold water. And you can begin to see that the temperature is going to start dropping rapidly. You can look at the graph here, it's trending downwards. On our panel view HMI, you can see that it is also trending downwards. The temperature is reducing. On the KTP400 connected to the Schneider, you can see that the temperature is also reducing. On our SCADA PC here, you can also see the decrease in temperature for the S7 1200, the Micrologix 1400, and the Schneider PLC. In typical applications like this, you would want to be able to detect communication loss between the PLCs. For that, we have written a program to detect communication loss. In my KTP400 connected to the Schneider, I have a communication status screen. So this shows that communication is active because the network is, the devices are transmitting data over the network. Now I'm going to pull the cable to the Micrologix 1400. The communication status should change to communication error. So I'm going to do that right now. I'll pull the cable and you can see that the communication status is now communication error, indicating that communication has been lost. Now if I plug it again, I expect that the communication status should change to active. And our communication status is active, showing that our logic works and the system performs what it's supposed to do. This is very useful for safety applications where you want devices to make decisions based on communication loss. So it might be to turn a motor off to prevent from hurting someone if the device is no longer getting communication. Knowing how to design and write programs for system integration is a skill that is very much in demand in the industry and will make you very valuable as an automation engineer. Thanks for watching.